right, class, we are looking at using some of this equations, and we're going to do one step and two step. This first one's on one step here. But the idea is some problem solving, looking at word type problems and then working those out, kind of setting stuff up and then working them out. A lot of this you could do using mental math, but we want to articulate and make sense of it in an equation format as well. So it says write the correct answer. Okay, I guess we'll do that. It says, let's see if we can go through and highlight some important stuff. First, I see $120 into her bank account. She now has $3,345 in her account, right? And solve an equation to find how much money was in the account before she made the deposit. So we start with like an initial amount. So we got like the start plus more, and then that equals like what we finished with. So let's kind of replace that with what's happening here. So we started with, we don't know. We'll call that the M. And then we're going to add to that $120. And then altogether, that's going to give us $3,345. And if we wanted to figure that out, well, that's just a subtraction, because we'd subtract negative 120 both sides. And then that would make a 0 here. We'd get M. So what's 3, 3, 4, 5 minus 1, 2, 0. All right, we got a 5, a 2, a 2, and a 3. So this is how much money we started with. That's cool. Right on. Max lost 23 pounds while on a diet. He now weighs 184. So this time, if we do a starting amount minus his loss, that gives our finish. So now we've got a subtraction happening. So he lost 23 pounds, and now he's 184 pounds, and that's what we're finishing at. So he's at 184, but he lost 23. So he started with some number, took away 23, and he got 184. Okay, so that would be, how much do we start with? We don't know, but it's telling us to use the letter W. So there we go. That's an equation for us. Let's see how much he weighed before. Well, we would add that 23 pounds back to see what he started with. And the W would come out to be, it looks like 207. There you go. Piece of cake. All right, next, let's just keep going on. We're on a roll here. This next one says, Maria earned $10.50 per hour. Per hour. That kind of sounds important. Working. She earned $147 each week before taxes, of course, because taxes just take like so much money. Write and solve an equation to find the number of hours H she worked each week. Well, let's see. If you count the amount per hour, so the money per hour times the number of hours, then that's the total salary, or the total money. So that's the total money. So now let's kind of split these things up. So H is going to be our variable here for hours. The amount per money, how much did she make? It looks like $10.50. And then altogether, that's going to be $147. Okay, so all we would have to do then is divide each of these by $10.50. Divide it by $10.50. Let's see how much she worked for that week. All right, so this makes a 1, 1050 over 1050. Over here, I got 147 over 1050. Now, that's not necessarily easy or obvious to do. It's not just like, oh, well, it goes in this many times. But I see a couple of things. I'm pretty sure I can multiply the top and bottom here by 2, so I'm going to multiply by 2 over 2. And that would give me on top, let's see, a 4, 2, 8, so 294 on top over 21 on bottom. And I think that I could simplify this. I think I could do maybe 3 into each of those, and let's see where that gets me if I divide each of these by 3. Because I know 3 goes into 21, I'm pretty sure it goes into 294 as well. So how many times does 3 go into 294? Well, 3 goes into 29 9 times, and that's 27. And then that gives me 24 left over, and this will be 98. Okay, Okay, so if I were to divide the top and bottom by 3, I would have 98 over 7. Now I could just do that division. Let's see how many times 7 goes into 98. 7 goes into 9 once, and then we have 2 and an 8, and that's going to be 28. So that's 4. So 14. 14. Now, if I really, really, really wanted to check this, I could just multiply 14 times $10.50. Well, 14 times $10 would be $140. 14 times 50 cents would be $7. Put those together, we get 147. So the answer is 14. I know I don't really leave much space here for an answer, but 14 is the number of hours for the week. All right. Ben is saving 1/5 of his weekly pay to buy a car. Write and solve an equation to find the weekly pay W that results in the savings of $61.50. Oh, okay. So how does this work? Okay, so we're saving 1/5 of our weekly pay, and if we're saving 1/5 of that, it's saying that the savings, that 1/5 savings, is $61.50. Oh, okay. Well, that's not too hard. Again, we can just make ones and zeros here. Let's make a 1 with this. It'll be 5 over 5. And we multiply both sides by 5. So 5 over 5 is 1. That's just W for his weekly pay. But over here, we got to multiply this by 5. All right. Well, 5 times 50 cents, that's $2.50. So let's see how much the rest is. 5 times 61, how much is that going to be? Let's see. 5 times 60, that's 300. And then a 5. So we got $365 from that. So we add that together, and we would get $367.50. All right. Cool. So those 4 problems worked out. Remember, these last 2 a little more challenging to see that. They're just not very familiar formats to set up, but still very doable. Let's take a look at the rest of this here. It says, use the table to answer questions 5 through 7. Okay, so it says, the speed of a snail is how many times that of a cat? Okay, so here's a snail. It's 0.03 miles per hour, and a cat is 30. Oh, now this is kind of weird. So the speed of a snail is, okay, so let's call that S for the snail, equals how many times that of a cat? So something times a cat. Okay, so let's call this X, and that's what we're trying to solve for. So we got the snail equals something times a cat. All right, well, how could we figure that out? Well, if we know that the snail is 0.03, or another way to think of that is 3/100, 3 over 100, equals, and then we got X times the cat over here is 30 miles per hour. That's pretty fast. So I filled in the cat and I filled in the snail. Now it's just a matter of getting this X by itself. So that would be divide both sides by 30, and we got 30 over times 100. So that's 1 over 1 on the right. That was easy. But on the left, we got 3 over 3, and then this is really a 10 times 100, or 1 over 1,000. So it looks like the answer would be A, based on my interpretation of this, because it sounded like the snail is so many times a cat speed. And that's how we came up with these multiplying and equals there. All right, a cheetah's maximum speed of 70 miles per hour is X times faster than a black mamba snake. Okay, so we have this is and X times black mamba snake. So, okay, so a cheetah, C, is means equals, so that's where we get the is. The cheetah is X times faster. So is X times faster than the snake's maximum speed. And what's a mamba? The mamba snake. Do we have a mamba in here? Yeah, we do. Black mamba snake, and that's 20 right there. So the cheetah is x times 20. But is there a cheetah in here? Oh, no, wait. It tells us what the cheetah is. It's 70. Okay, so that's going to be 70 equals 20 times x. There we go. All right, and which one? Oh, here we go. That would be J. That's our answer there. All right, let's look at the last one here. It says, use your equation problem 6 to find how many times faster a cheetah is than a black mamba snake if they're both traveling at maximum speed. Ooh. Oh, wait. Okay. How many times faster a cheetah is than a black mamba snake? So this number should be big, is what I'm thinking. It should be more than one because a cheetah is definitely faster than a snake. All right, so let's see what this would be. So we'd have 70 equals 20x. And it says use our equation. I'm guessing they're wanting us to get that x by itself. So if I were to divide both sides by 20, and that gives me 1 over 1 on the right. On the left, 70 over 20, I could divide each one by 10 and I get 7 halves. Now, I don't see 7 halves here. But I know that 7 halves is close to 3, so I'm thinking it's this one. Let's double check with some long division. If I were to do 2 into 7, 2 goes into 7 3 times, and we're left with 1. But 2 doesn't go into 1, but it does go into 10 if we were to drop a decimal down. So that would make it 3.5. So there we go, 3.5 times. The answer would be B. Remember, to get credit for this, you do have to show all the work, or at least some of the process in your own version there. And then we're going to show the problem solving for section 2.2 as well.